So folks, in the last pre-work, we looked at a whole variety of different types of functions that we're going to be studying throughout this course. And so finally, we're ready to start talking about extending the idea of calculus that you did in Calculus 1 to these other types of functions. So in a somewhat facetious example, I want to look at this example here, where I've got a function f, and so the function f is defined by what it does to all of these elements in the domain, which elements they get mapped to. So here's our domain set that we talked about, and here's our codomain set that we talked about, and the element 1 in the domain set gets mapped to the element k in the codomain set, and 2 gets mapped to m, etc. This is a perfectly well-defined function. This meets every criteria for a function. So let me ask the somewhat facetious question: can we do calculus with functions like the one depicted above? And the first answer is, of course not. Or rather, probably not. And let's explain that. We would expect expressions like saying, what's the derivative of this function, or what is the area underneath this function's curve from the domain value 1 to the domain value 3. We would expect those to be essentially meaningless questions, and they probably are. But that kind of gets us ready for where we're going. In the last pre-work, we looked at vector-valued functions. So here we have a vector-valued function that maps the element t to some vector x, y, z in 3 space. So we've got a vector-valued function going from the domain of the real numbers to the space of 3-dimensional vectors there. And here I've described it. So let's ask this question: what makes us think that we can extend calculus to vector-valued functions? And it's a good question to ask, and it's one that maybe you think you already know the answer to, and that's great. But I would say that throughout your math career, you kind of want to be asking the question, where can I extend calculus? And the answer is, you can extend calculus wherever you can define limits. As long as you're able to define limits, you can define all of the objects that we defined in Calculus 1. But then the question is where can you define limits? And the answer is, you can define limits wherever you can define a notion of length. So it boils down to being able to talk about length. And in the next couple of videos, we're going to look at limits of vector-valued functions. We're going to give a definition for them. Once we've got a definition for limits, and once we can take limits of vector-valued functions, then we will be able to bring in notions of derivatives of vector-valued functions and integrals of vector-valued functions, and a few of the other objects from Calc 1, as well as some new objects that we'll get to study throughout the course of this chapter. So join me in the next video, and I'll see you there.